So we've defined all of these quantum numbers, these new quantum numbers that are combinations of our individual electron quantum numbers. And without a concrete example, the question is really like why and how does this apply and what is this all about? So let's consider an atom where we have two valence p electrons, something like carbon, right? Where we have two p electrons, two 2p electrons, I should say. So if we're looking at carbon, we have two electrons in p orbitals. There are lots of different ways we can arrange those electrons, right? So we have three different possible m values. And this, to be specific, this is m sub l, right? M sub l could be equal to -1, 0, or +1, because for a p orbital, that means L is equal to 1. That's the definition of a p orbital. And if we have two electrons here, there's lots of different ways we can arrange these. So if I just kind of keep to this notation here, with the left hand side, we have a -1, 0, and +1. So we could have our two electrons are both in the -1, m sub l -1 orbital. We could have a different configuration where we have one spin up in each of the -1 and +1. Or we could have one electron spin up, one electron spin down, right? You can see there's lots of different possible combinations here. And it turns out that the energy of our system for these different configurations, there are groups of these that will go together that will, follow the sort of quantum numbers that we've defined. And there'll be distinct electronic states that have specific energies. So these different configurations of electrons have very different energies. It's not just a little bit different. Sometimes it's only a little bit different, but usually it's a quite drastic difference in energy. And this is how we classify these different possibilities. So we're going to start simple. This is actually a little bit more complicated case. Let's get rid of some of our orbital angular momentum, and we'll start with something where we only have two electrons in an s orbital. And we'll look at that in the next video.